Okay, welcome back to the deep dive. We've got some interesting source material here today.
Yeah, it lays out a really kind of neat connection, actually.
Right, between a math concept you might be, wrestling with right now.
Huh? Integration.
Exactly, integration, and how it connects to, well, a very real-world problem.
That's right. The sources basically show how this calculus tool helps us understand things that, change over time, quantify them.
And this deep dive is especially for you if you're maybe in college working through differentiation and integration right now,
Yeah, we're zoning in on one specific application that these materials highlight.
which is using integration to estimate the total growth of a pest population.
Right, like over a whole crop season.
Mm.
It really takes that sort of abstract math idea
Hmm.
and plants it firmly in, well, a field.
Okay, so here's where it gets interesting, right? You're probably learning integration is basically about summing up continuous change.
Yeah, finding the total accumulated stuff when you know the rate it's changing, like
Yeah.
at any given moment.
So the sources show that if you have, let's say, a model or just some idea of the rate pests are increasing,
Day by day or week by week.
integration lets you calculate the total number of new pests, like the total increase over the whole season.
Exactly. That's the total number added.
Think about that for a second. It's not just how many pests today,
No, it's the bigger picture, the cumulative impact.
which, if you're in agriculture, seems pretty crucial, for deciding when to treat, if to treat.
Absolutely.
Yeah.
Knowing that total potential growth informs those big decisions.
Hmm.
Crop protection strategies, timing, all of it.
And the sources really hammer this home. This is why integration is the right tool here.
Right. Differentiation gives you the rate right now. Instantaneous change.
But integration deals with the accumulation, the result of that rate adding up and up and up over a period.
Precisely. It's built for problems just like this.
Yeah.
Figuring out the total amount from a known rate of change.
Yeah. So what these sources are showing us, really, is how integration, the thing you're studying, directly connects to solving this practical problem, estimating total pest growth.
Summing up that rate of change over the season.
It bridges that gap,
Yeah.
between the math textbook and, well, actual buds on actual plants.
Yeah, and looking at it through the lens of these materials, it just demonstrates that calculus isn't only theory. It's really a toolkit.
A toolkit for looking at systems that change.
Exactly. Dynamic systems. And putting a number on the total outcome in the real world.
Okay, so based just on what these sources laid out, here's something maybe to mull over.
Right.
We've seen integration estimate total change using this pest example over a crop season.
Right, adding up the growth rate.
So given that it's about quantifying that cumulative change, what other real-world things, processes maybe you see every day that involve stuff building up or changing over time,
Yeah.
might this math tool integration actually help you understand or, put a number on?